Hello everyone, once again another little video on how to intercept the ILS on profile. When you are flying the ILS, where you intercept the 3-degree glide path matters in that whether you will be high or low. Normally all ILS glide paths are meant to be intercepted from below, so that as you're coming into your final approach fix, your aircraft is below the glide path, and once the aircraft hits the FAF, final approach fix, then it starts going downhill as it has captured the glide path. But where you will be on your intercept heading will matter whether you will be high or low. So I just want to first of all show you a diagram and explain to you on what the diagram means, and then we are going to investigate an approach plate for Lusaka, and then we will do a simulation to show you exactly how the aircraft's instrument look like depending on where you are intercepting the glide slope. So here now we have the a little diagram which I have drawn. What you have here in blue is a flight path of your aircraft, and the green is your 3-degree glide slope, and this is the runway. This star here is your final approach fix, where you start going downhill once you capture it. So we can capture, if you follow the cursor, we can capture the glide slope from anywhere we want actually, but the best way is to be under the glide path than above it. If I turn to an intercept heading from this position here, as you can see where my cursor is moving, you can clearly see that I'll be high, so I'll have to dip down, okay, significantly as well depending on where I am, to catch the glide path. This is not a very safe and comfortable maneuver. So it means that if you have intercepted the glide slope after the FAF, we are reading from left to right, so after means after the FAF, you will be high. So to quickly capture your glide path, you need to set a low altitude. The minimums would be fine because you will get to the 1-2 level call quite early. So you will set a lower altitude, and then you will engage vertical speed, and then you will have to go down until you capture your glide slope, because the glide slope in this case is below you. So this, as I said, is going to be like a dipping down sort of maneuver, and it's not very comfortable, especially if you are doing commercial flying. You avoid as much as possible to do such what we call kamikaze type of approaches. Okay, so this is going to be putting you on high on profile. If you intercept the glide slope exactly at the final approach fix here, then this is called a platform altitude. Okay, so it will exactly nail you on the glide slope. So this is another way of radar vectoring you exactly to the final approach fix. However, you can still go a bit further out, and then you can intercept, you can make a turn, as you can see where my cursor is following, and then you can be below the glide path, or glide slope rather. So you can see right now you are below the glide slope. So if you intercept before the FAF, as I said, we're reading from left to right, you'll be below the 3-degree path, and once level on the dotted line here at the platform altitude, meaning the altitude which you capture your glide path at final approach fix, you will intercept the glide slope at the FAF. So you'll be coming in like this, and exactly at the FAF, the glide slope will be captured. The glide slope is above you. It will be coming in slowly as you're approaching the FAF, and there you go. You are going to capture the glide slope from exactly the FAF, but from below. This is a bit more comfortable maneuver. If they are radar vectoring you, they might ask you to intercept the glide slope, or if you can manage to intercept the glide slope at any particular point. But normally they will intercept. They'll give you intercept headings which either give you an intercept exactly to the final approach fix, or they take you a bit further out so you can comfortably come and go below the glide slope and then catch the glide slope. So you can see the difference between intercepting from above and intercepting from below, and normally you intercept the glide slope from below. Okay, in the next slide we're going to check now at the approach plate for Lusaka. I won't go into the full details of it because it's not a briefing of how to read an approach plate. That's another lesson, but we're just going to take the main points. I advise that you keep this approach plate somewhere on your screen, or maybe screenshot it so that maybe you can follow when we do the simulation. So here we are with the ILS approach plate for Lusaka's Kenneth Kaunda International Airport, and this is the plan view and this is the profile view. If you can see the difference, this fan here and this fan here, they're different in length, simply because this fan here is for the localizer intercept, and you intercept the localizer at a point called Atuli on this particular approach, and you intercept the glide slope at a point called Kilo 100. This is the Lima Oscar, it's a NDB, and it is 5.4 miles. This point here rather is 5.4 miles from Lima Oscar and 4.5 miles from the VOR, which is Victor Lima Sierra. So we will tune in Victor Lima Sierra once we set the aircraft exactly to intercept this point, and you will see on the DME it will be 4.5 or somewhere around there, and then you will see the aircraft will exactly intercept on the proper point for it to go down. We will also show what will happen if we came, let's say, from this particular point here and dip down, and we'll also show what will happen if we go a bit further out and then we come back and we come this way and intercept the glide slope from below. So what you want to appreciate here is how your instruments will be looking depending on where you are. So a quick review again, just a quick one. I'm not going to go through the whole ILS plate here. This is a subject of another lesson, which I should be making another video of in the coming days. So localizer is this one, as I've said. Always on the plan view you have the localizer fan, and how you know it's a localizer fan, the right hand lobe is always shaded in gray color or in dark color than the left hand lobe. And then this one in the plan view will also be the ILS ILS intercept point, and you can clearly see that localizer has to be intercepted before the glide slope, as we normally do, and that's a rule, so that you don't intercept any false signals. So the localizer can be intercepted around Atuli, a waypoint called Atuli, and the glide slope then can be intercepted at Kilo 100, which is 4.5 miles from the Victor Lima Sierra VOR, or 5.4 miles from the Lima Oscar NDB. Okay, having said that, now let's jump into the sim, the Majestic that I normally use to demonstrate such and other cases, and then maybe you might be able to appreciate on how it all is. So let's go and now talk on the sim. Okay guys, so here we are in the Majestic software, which I normally use to do some demonstrations and to do my own practice. It's a very helpful tool actually, if you can get hold of that one. So I've set up the aircraft airborne already, and I just want to take you through a few things that are there. Don't worry about this glide stop signal. Normally it has to be there, but you know, some of these software glitches that we have in these softwares, we cannot do much about them. So the main interest here is to show you the important points and what's actually happening. So what I've done here is that I've reverted to blue needles using my nav source here, because I'm assuming that we are being radar vectored. Okay, now one more thing I want to do, I didn't do it deliberately because I want to show you how to do it, is to extend the center line. If I bring up the MFD, you can see the center line through here is not extended. Okay, but I did it deliberately so that I show you how to do it for those of you who don't know how it works, and then from there we can get the center line and all the intercepts and all that. So I'll pop up the FMS here. The FMS is pretty much a bit more similar, and a few things are the same in the actual ones, but this will, I think, do the job for now in as far as we are concerned, to show how the radar vectoring works. So whenever you're radar vectored, the first thing you do in this aircraft, you engage vertical speed, heading select. That's the first thing you do. okay, because now you're on radar vectors, so you are not following the LNAV profile, okay. But for situational awareness, to see where your aircraft is in relation to the runway, you extend the center line, which is a proper phraseology to be used. So to do that, here's what we do. We go to nav, and nav page, we go to maneuver, and maneuver, we go to what you call PVOR or pseudo VOR. When I do that, I'm given some options here on the left side, asking me from where do I want to extend the center line. So what we're going to do, we're going to extend the center line from the course intercept 10, CI 10. So I'm going to type in here 2, and then I'm going to say enter. Then I'm going to go to the next line select key on the right hand side, which is going to ask for the desired track, and desired track is runway heading, which you recall from your chart is 100 for runway 10 in Lusaka. When I press enter, I'm given the option to accept. So here I go, I accepted it. Now if I see the MFD, look what has happened. Now we have a pink, magenta rather, dashed line through CI 10. Okay, that's very important. Now what is happening here is this. CI 10 is our course intercept. Okay, that's where we want to actually intercept the localizer. Where I've put the aircraft here deliberately is to put it exactly at the intercept point, the final approach fix. Okay, and see what happens as the aircraft approaches the center line, the extended center line, and see what happens to the glide stop signal. As I said, from this distance, in reality, this glide stop signal should be giving you shouldn't be giving you an X here at all. But as I said, this is a software issue, so we can't do much about it. So I'm going to unfreeze the simulator now. I'm going to unpause it and then see what happens as we're approaching the center line. Right now, we are 6.1 miles from the extended center line of this runway, and I have armed the approach mode. So the approach mode is on the FGCP. It's a button which is just there, okay, and it's giving me localizer armed and also glide slope armed. Okay, so now we unfreeze the simulator and let the aircraft fly. Don't worry about this indication. As I say, it's always a software issue on such systems. So the main thing is to show you what we actually want to show you. So another thing as well, the minimums for the ILS for Lusaka is 4100, just to the nearest 100, which I've set here on the MDA, and the rest I'll show you as we go along. So let's unfreeze the simulator. So I just had to adjust the heading here. The heading was a bit incorrect because it was meant to be 190 for the thing. That's why we saw the aircraft turning, which isn't a good thing, but we have to put the heading at 190, which is at right angles to the center line. So I'll unfreeze it again, and sorry about that. I was just like and it's going to take a bit of a delay here, the usual software issues. And let's see what happens when we intercept it exactly at now you can see what's happening to the glide stop here. Can you see the glide stop here? You can see the glide stop is coming. So here we are. The glide stop is being intercepted exactly at the final approach fix. So there we are. And once the diamond, this glide stop here is exactly at the center, I'll pause, and then I want to remind you of something that we saw on the chart. So look what happens as we near the center line, and once you're on the center line, the glide stop pointer should be exactly at the center. Okay, so see what happens there as we approach the center line. Right now we are 4 miles from the center line, as shown on the MFD on the top right corner. Here we go. Glide stop and lock have been captured. As you can see, lock and glide stop has been captured, and we are there. Now, if you remember what I told you, that the final approach fix, the KK100, is around 4.5 miles from the Victor Lima Sierra. What I've done here, I have tuned in Victor Lima Sierra on the ARCDO, which is 113.5. I'm going to activate it now so you can see the DME distance here, and it should be somewhere around 4.5 miles, and then we'll revert back to the ILS, and that will be done for this part. Then we'll talk of intercepting the glide slope before this part and after that part to show you how the indications look like. So let's press this one to activate the Victor Lima Sierra. And can you see this distance here? 4.6 miles. Right in the corner here is 4.6 miles. That is exactly where the final approach fix is. So very important that you know that when you intercept the glide slope at the final approach fix, you are going to come bang on at the platform altitude of 5,500. You won't be high, you won't be low. Okay, so I'm going to put this back into the system. The basic modes have pitched up on the FMA, which we can always change. We can always change the basic modes, and that will be basically heading select and alt for now, like this. Okay, so I'm going to stop this demonstration here. The next demonstration will be to intercept the glide slope from after the final approach fix, as we discussed, and also before the final approach fix. In that case, you will see that we are coming in high and coming low. Okay, so this would be it for this demonstration. Okay, so here we are again. This time what I've done, I have actually positioned the aircraft slightly closer to the runway, let me put it that way. So it's like after the final approach fix. So again, I'm going to unfreeze the simulator, and then you will appreciate that when you are closer to the runway or you are after the final approach fix, you will be very high on profile, in which case you'll have to definitely abandon the approach because it's very unsafe, or if it's doable, you can go to vertical speed, set a lower altitude, preferably the minimum, which is in this case 4100 with all sail on the altitude, and then use a high rate of descent to capture the glide slope. All I want you to know here or do is to appreciate how the glide slope indicator will look like when you are closer into the runway than exactly being further out. So let's unfreeze the simulator and see what's happening. So here we are approaching the center line at 6.7 miles as shown on the top right of the MFD. And don't worry, as I said again, about this red cross on the ILS indicator. Normally it should be showing in reality, but when it pops up, when the system dictates that now it's running, there we go. Now look what is happening. I'm going to pause the simulator. Look at what has happened. Can you see the glide slope indicator? You can see that you are very high because the glide slope indicator is very low. If the glide slope indicator is very low, it means you are very high. So here's what happens when you are closer into the runway or intercepting the glide slope after the final approach fix. So you come in high. If you review the diagram which I drew or which I sketched on the presentation, you will actually appreciate a three-dimensional scenario on this sort of situation. Okay, so this was about it basically. I didn't want to show anything else on this one. Now we can go and set up the simulator again and to show you how it looks like if we intercept the glide slope further out, so away from the final approach fix. And that should be I think taking us towards the end of this understanding, and I hope you will understand it. So let's jump into the next demonstration. Okay, so here we are on the last of the presentations to understand how it would look like if we intercepted the ILS glide slope from further out. So what I've done here now, I have positioned the aircraft just perpendicular to the course intercept, where normally you intercept the localizer. Okay, so here you intercept a localizer if you reach this point, and thereafter when you turn, you'll intercept the glide slope from below rather. So I'll unfreeze the simulator again and see how this approach is a much better way of intercepting a glide slope in a more comfortable way, and if also a more safer way as well. So I'm unfreezing it now so you can see what has happened again. Lock and glide slope are armed, minimums are set, and correct sensing on the EHSI on our HSI indicator here. Correct sensing meaning, very important to understand the correct sensing phenomenon, is that we are coming from the north, from northern side, so we want to intercept the localizer on the opposite side. You can see that we are coming from the northerly heading and the localizer is on the southerly heading. That's called correct intercept. If this localizer indicator was on the same side as we are coming in from, then that's a problem. So always correct sensing is important. When you have correct sensing, initially it's already fluctuating until it fixes itself onto the correct intercept profile, the localizer. And that's when you're going to push the approach button, approach mode on the FGCP, so you can get lock and glide slope armed. Otherwise, if you push it prematurely, you may intercept a false localizer, which will take you down into a CFIT situation, which I don't think you want to be in. Okay, so that was just a bit on correct sensing, because I used the phrase correct sensing, so I thought I should explain to you what correct sensing actually means. So here we go. Let's unfreeze the simulator and see how the glide slope indicator look like as the aircraft approaches the course intercept 10. We're coming in 2.4 miles now from CI10, as you can see, and in this case we will be intercepting localizer. You can see the mini needle here is moving now, so localizer is coming alive gradually. Of course, the sensitivity of the sim also matters in this case, like the software which we have on this PC. There we go, localizer is captured in green, and the aircraft is now going to turn towards the runway. So you can see that we haven't yet captured the glide slope yet. Here you can see still glide slope is armed. So in this situation, of course, we set runway heading. So we're going to set runway heading to 100, which I'm doing now. There we go. Whenever you capture the localizer, you set runway heading, which is sorry, that was just a bit too much sensitivity issues again on the oops, why does it not just give me the right thing to start with? Okay, there we go, 100. So 100 is set, and the aircraft is now coming in on the localizer. So it will try and intercept the localizer until it establishes itself on the center line. So you can see the CDI is moving. Here we go, look at the glide slope now, coming in comfortably from the top. So we are coming in from the bottom, and as soon as the glide slope centralizes, that will be at the final approach fix, the aircraft will be nailed onto the downhill, and it's going to start descending on its own. So there we go. In this configuration we'll do gear down, flap 15, condition levers max, bleeds to main landing checklist and the like. There we go, the glide slope is coming in comfortably. Here we go, glide slope is captured in green here, and the aircraft starts descending. There we are, and the aircraft goes towards the 3-degree glide slope. That's it. I just wanted to explain to you that on the 3 different types of intercepts. I hope it's making much more sense now. We're not going to do more. Thank you very much, and just remember, very important is that when you intercept the glide slope after the final approach fix, you will be high, and if you intercept the glide slope before the final approach fix, you will be low, which will be a good thing to do. You'll be more safer, and you'll intercept the glide slope from below rather than from above and having to do vertical speeds and diving to catch your glide path. Till the next time, till another video is coming up, enjoy yourselves in your flying, happy landings, and yeah, do drop some comments if you can, just to make me aware on what I should be explaining to you more, or as I come to know more, the more I fly the aircraft and the more experience comes on. Thank you very much, and God bless you all.